Yes, dear children, today we are going to study about the topic sulfuric acid. Now, sulfuric acid, first topic we are going to study its behavior as an acid when it is dilute. Now, dilute sulfuric acid behaves as an acid how when in the dilute condition. That is because of the presence of hydronium ion that is formed when sulfuric acid it dissociates in aqueous solution. So now dilute sulfuric acid it turns blue litmus paper red and methyl orange pink, that is for the identification of sulfuric acid. Now the general reactions of dilute acid is first active metal except lead plus acid it gives salt plus hydrogen. We can take example of any active metal, like if I say magnesium plus sulfuric acid dilute forming salt, that is magnesium sulfate plus hydrogen gas. Now the second reaction is base, whether it is oxide or hydroxide of a metal, it will always give salt plus water. Now here we can take example of any metallic oxide or hydroxide. For example, if we take zinc oxide plus sulfuric acid, dilute sulfuric acid, it will lead to the formation of the salt zinc sulfate plus water. Salt plus water. Only we have to keep in mind the statements of all the reactions. Now the third is metallic carbonate or bicarbonate plus acid gives salt plus water plus carbon dioxide. And for this reaction we can take example of any metallic carbonate. If I take sodium carbonate Na2CO3 plus dilute sulfuric acid, first I said salt is formed, so sodium and sulfate will form sodium sulfate salt plus water and plus carbon dioxide because of the presence of carbonate. Now after that, metallic bicarbonate. If we take sodium bicarbonate plus sulfuric acid, we have to mention whether it is dilute or concentrated, and here we are doing all the reactions taking the example of dilute sulfuric acid. So the salt formed will be sodium sulfate plus water plus carbon dioxide. So you have to balance the equation after writing it. So So now this is the reaction for metallic carbonate or bicarbonate with dilute sulfuric acid. Now metallic sulfide or bisulfite, metallic sulfide or bisulfite plus dilute acid will always give salt plus water plus sulfur dioxide gas. So now if we take example of sodium sulfide plus dilute sulfuric acid. Now first the salt will be formed, that is sodium sulfate plus water plus sulfur dioxide. Now it is in the balanced form. So now the next is metallic sulfide. Number 5 is metallic sulfide plus dilute sulfuric acid. It will give first product as salt and second product as hydrogen sulfide gas. So taking example of sodium sulfide plus dilute sulfuric acid giving the product salt plus hydrogen sulfide gas. So here we have seen the behavior of sulfuric acid when dilute. Now coming to concentrated sulfuric acid as an oxidizing agent. Now in this we will be taking example of oxidation of carbon and sulfur. Oxidizing nature of sulfuric acid. So now oxidizing behavior with carbon and sulfur. Now carbon plus sulfuric acid will give first product. The oxidized product will be carbon dioxide plus water and sulfur dioxide. So what is the oxidized product over here? That is your carbon dioxide. Now after this we are going to balance, and here we are going to write down the acid whether it is concentrated or dilute. So we are using concentrated sulfuric acid and as an oxidizing agent. So after balancing the equation we will be getting the equation like this. So now again the oxidation of another non-metal, that is sulfur. So sulfur plus concentrated sulfuric acid, the oxidized product will be sulfur dioxide plus water. So this is the behavior of concentrated sulfuric acid as oxidizing agent. Now coming to the next, that is concentrated sulfuric acid as a dehydrating agent. Now as a dehydrating agent, what do you mean by dehydrating agent? Concentrated sulfuric acid, it removes elements of water as it is having strong affinity for water. Then concentrated sulfuric acid also removes the water of crystallization from hydrated salt. Again, concentrated sulfuric acid, it also acts as drying agent. Here we are going to study how concentrated sulfuric acid, it behaves as a strong dehydrating agent. So now here we are going to take example of dehydration of sugar and copper sulfate crystals. Now sugar, that is your C12H22O11, we will be seeing that concentrated sulfuric acid, it will remove the water molecules which are present over here. So we will be seeing here that only carbon is left, and so after balancing the equation, 12 carbon atoms, and here we see 11 carbon 11 water molecules along with the 12 carbon atoms. So now after this we will be taking the another example of copper 2 sulfate. So copper sulfate we write as CuSO4 into 5 molecules of water. So concentrated sulfuric acid, in presence of concentrated sulfuric acid, the molecules of water, it will be removed. So now we will get the copper sulfate as a white anhydrous salt. So the water of crystallization are removed completely. So earlier the copper sulfate was having blue color and it was an hydrated salt containing 5 molecules of water. Now it has changed to anhydrous salt and 5 molecules of water, they are removed. Now the non-volatile nature of sulfuric acid. Non-volatile nature of sulfuric acid. Now for non-volatile nature, we will be taking example of sodium or potassium chloride. Now sodium chloride, sulfuric acid, that is your concentrated. So we will be getting first of all the acidic salt, that is sodium bisulfate plus HCl gas, which will be also evolved. The temperature maintained over here will be 200 degrees Celsius, less than 200 degrees Celsius. So this is the reaction of sodium chloride with concentrated sulfuric acid to show the non-volatile nature of sulfuric acid. So now, dear children, I think that you have got all the reactions whichever I have told you in this chapter. So that much is according to your syllabus. So go through this video and learn and do practice of all the equations, and so this much is there in your sulfuric acid. So in the next class we will be revising about the reactions which are included in the nitric acid and ammonia. So thank you very much, dear children, for watching this video, and have a wonderful day ahead.